The New York subway tunnels haven't heard human footsteps for 15 years. But if you listen carefully, there's a new rhythm echoing through these concrete caverns, the steady drip of seawater, seeping through forgotten maintenance shafts, each drop adding to the rising tide below. But here's the thing. This isn't a story about decay. What you need to understand is that beneath Times Square station, where 8 million people once rushed to catch their trains, bioluminescent algae now paint the submerged cars in ghostly blue light. Schools of fish navigate through turnstiles that no longer turn. Nature has claimed these tunnels not as ruins, but as the foundation for something extraordinary, Earth's newest coral reef system, growing in the darkness where humanity once moved like blood through veins. The last subway train pulled into Grand Central at 3:47 a.m. on a Tuesday that no one remembers. Within days, the pumps that kept 14 million gallons of groundwater at bay fell silent. One by one, across the world's coastal cities, Tokyo, London, Mumbai, the underground arteries that once carried millions began their transformation. First came the darkness. Emergency lights flickered their final moments as backup generators exhausted their fuel. Then came the water, not in a catastrophic rush, but as a patient invader, seeping through cracks, pooling in low points, rising inch by inch through the platforms where commuters once waited. The Atlantic Ocean had been pressing against New York's foundations for centuries. Without human intervention, it took just 6 months for seawater to claim the deepest stations. The subway maps on tunnel walls became depth charts, their colored lines now marking the boundaries between air and water. Before the water fully conquered the depths, something unexpected happened at street level. Moss appeared, first emerald patches spreading across station entrances like living graffiti. Tree roots, sensing opportunity in the absence of maintenance crews, began their slow but relentless push through sidewalk grates. Within 3 years, Central Park's edges blurred as vegetation spilled into Columbus Circle Station. Vines descended the stairs like curious explorers, their tendrils wrapping around handrails, creating vertical gardens in the twilight zones where sunlight still reached in the flooded sections below. A different kind of growth began. Algae bloomed in spectacular diversities, some species producing oxygen, others glowing with bioluminescence inherited from genes that evolved in ocean trenches. The concrete walls, once sterile barriers, became surfaces for biofilms that would form the foundation of an entirely new ecosystem. They came through the storm drains. First small fish, following the salt gradient upstream into this vast network of artificial caves. Killifish evolved to survive in puddles, found paradise in the shallow platform pools. Behind them came the crabs, their shells clicking against the tiles as they established territories in the ticket booths. 5 years in, something remarkable occurred. Marine biologists studying the phenomenon would later call it accelerated adaptation. Fish populations weren't just surviving, they were evolving. The constant darkness selected for enhanced lateral line systems. The maze-like tunnels favored smaller, more agile species. Octopi discovered the subway cars, transforming them into elaborate dens. Their intelligence found new expression in this architectural playground, using the grab handles as anchor points, the seats as nurseries. One species developed a hunting technique using the car doors, learning to create currents that drew prey inside by year 10. Harbor seals had established a breeding colony in what was once Penn Station. Their calls echoed through the tunnels, a haunting chorus that replaced the screech of brakes and the automated announcements that once directed human traffic. Scientists studying these flooded metros made discoveries that challenged everything we thought we knew about ecosystem recovery. The heavy metals in the tracks, the residual chemicals from a century of human use, none of it stopped life from thriving. Instead, certain bacteria evolved to process these toxins, creating the foundation for a food web that shouldn't exist. The concrete itself became a calcium source for shell-building organisms. The steel rails, slowly rusting in the salt water, created iron-rich zones where unique bacterial mats flourished. These mats attracted small crustaceans, which drew fish, which brought larger predators. Most remarkably, the subways structure its tunnels, platforms, and connecting passages created a series of micro-environments. Each station developed its own ecological signature. Times Square, with its slightly higher temperature from residual electrical infrastructure, became a nursery. Grand Central, with its vast open spaces, evolved into a hunting ground for larger predators. The electromagnetic fields from deteriorating cables created navigation channels that some species learned to follow. The subway map, in essence, became encoded in the biology of its new inhabitants. 15 years after the last human descended these stairs, the subway has become something unprecedented. Massive artificial reef system, stretching for hundreds of miles beneath the city. Marine biologists call it the Anthropocene Reef, a testament to how nature adapts to and transforms human architecture. Coral species, carried as larvae from the warming Atlantic, have begun colonizing the platforms. They grow in patterns that follow the tile work, creating living mosaics that mirror the artistic intentions of long-dead designers. The Metropolitan Museum of Art lies empty above, but below, nature has created its own gallery. The deepest stations have become abyssal zones, home to species typically found in ocean trenches. Bioluminescent jellies pulse through the tunnels like living constellations. The pressure differences between levels create currents that circulate nutrients, turning the entire system into a breathing organism. Standing water now reflects nothing but darkness in these tunnels. Yet they show us everything about our place in the world. We built these subways to last centuries, engineering marvels meant to outlive their creators. We just never imagined they would serve a different purpose. This transformation asks a profound question. Were we ever really in control? Or were we simply another species modifying the environment for the next inhabitants? The subway thrives not in spite of our absence, but because of it. Our greatest infrastructure project has become proof of life's fundamental truth: it doesn't need us. Perhaps that's the most humbling revelation of all. In the dripping darkness of these flooded tunnels, in the ghostly glow of algae on abandoned trains, Earth is writing a new chapter. And in this story, humanity is just the prologue. The trains no longer run on time. They've become time itself, markers of an era when one species moved through these tunnels, before the ocean reclaimed them for countless others.